Okay, so this is the code for the knock lock. So I'll give you all a walkthrough of how it all works. So first, we use a servo to control the lock mechanism. So we have to include the servo. And I can name the servo door for convenience. And then I'm going to set its open position to 30 degrees and then its closed position to 140 degrees. So fairly simple. And then we're going to include pitches after. So pitches is a library that allows us to play sounds. So if you get the password wrong, it plays like an incorrect sound, and if you get the password right, it plays a correct sound. And this is the melody for the incorrect sound, and then this is just the note durations. So this all controls how it sounds, and this is the melody for the correct sound. And I just call this one melody, and then I call this one correct melody, and then this one's wrong melody. So if you get it wrong, and this one's just a basic one. This one right here is when we scan the card, it lets us know that it registered the card and it's in the system. That's what that melody is. Yep. And then this is interesting right here. So I didn't display this in the other video at all because I haven't implemented it yet. But this is a capacitive sensor. So the way this works is whenever you touch a wire connected up to a pin and you touch a bare metal on the wire, it registers it as a capacitor, and then the Arduino can sense that a capacitance has changed, just like how a touchscreen works. And it can use that as a signal to do other things. So my plan with this was, if the password is correct and a certain switch is turned on, when you touch the doorknob, it automatically opens up. So you don't need to like keep redoing the password or whatever. But the only problem is Arduino has to be on 24/7, and I don't really, even though it's not that power hungry, I don't really like to keep it on 24/7. So I really haven't implemented this yet, but it's in the code. So if I want to do it one day, I just have to wire up one switch, and it's very simple. So this is also the servo. Uh, don't know why I included it twice, but I did. That's a bug. I'll just delete that real quick. So this also registers the capacitive sensor, and then give it a long value for timing purposes later on. And then this is the RFID module right here. And we're going to set the pins up. So pin 53, that's the pins that only work on the Mega. And then the reset pin, which is 5, which it can only be specific pins, but you have more pin options for the reset pin. And then these two are the cards right here. So these are the two codes for the cards. And this is the other code for the other card. So only these two codes open the door. And then this is the knock sensor right here. So the knock sensor is just a speaker, because speakers can produce sound, and then they can, like a microphone, register sound and vibrations. So you can also use I don't even know how to say this, a piezo sensor. I know what it is. It's just a little sensor that does the same thing, but unlike a speaker, it can't play every sound. It can only play notes. So, but it might actually be more effective than just a speaker. I just don't have one of these around, so I have to use a speaker. So we're gonna put this one up to analog 0. It's an analog signal, and we are going to. So I sold this code off of somebody else, and he used it for a slightly different purpose. I really didn't change most of it, even though I could have, but it does not affect the performance at all. So I was just like, I'm not gonna change it. So we don't use the LEDs for like a status. We use the speaker instead. But he wants to use LEDs, so this is what he has right here. So these are all interesting. So this is the threshold value. So what kind of signal needs to go in for it to register? I picked a very low one because that's the only way you could pick up a vibration, is if it's really low. And then this is a reject value. So if it's off by this certain percentage of the knock, then it doesn't it won't register it. So you can play around with the setting. 40 worked pretty well for me. And then same thing, these are all just timing stuff. And then this is if it doesn't see a lock within 1.2 seconds, then it just declares it done. So this is the secret lock code right here. And wait, give me a second. Yeah, so it's it goes by like a note system. It's like quarter notes, like full notes, half notes, something like that. And so if you know like music theory, then you can easily set this up by yourself. So now we're gonna go and then I have a little true or false thing. So the Arduino always knows, is the door open or is the door not open? So is it open? It's false right now because when you turn the Arduino on, I want it to be closed, so you can't just turn it on, it just opens. And then you see he has the pin modes for these outputs or whatever. This is for the inputs, so the switches. So I have one switch that puts it on RFID module mode, and another switch that puts it on knock log mode. You can't have them really running both at once because they're quite demanding for each other. So I just have one run at this one time, the other one run at the other time. And then we're gonna attach the door to the second digital pin. And we're gonna, basic stuff, begin the RFID module, whatever. So if the digital pin 9 is high, then if we touch the doorknob, it's gonna open up automatically. So that's what all of this means right here. But I did not highlight this because I did not implement it yet. So this is the knock lock sensor right here. So it uses a couple like functions voids. So we'll go look at this after. But yeah, so knock lock, it just reads the sensor, gets the value, and then um yeah, see we have this right here. Listen to the secret knock. We'll look at the code after. It's below the void loop, and then yeah, I can detect it after. So and this is the RFID module right here. You know, so if the switch is low, then we put this module goes into action right here, and it's pretty simple. So yeah, so yeah, if it gets a card, like new card is present, well, then we play this melody right here, and then we make sure that the card matches with the numbers that we have stored in here. And if it is, then the door is open. So we set this to true, and then we play the open sound, and then we wait for a little bit. Where's the delay? Yep, delay. Pause between that's pause between notes. We delay for 2 seconds, and then we close the door. So yeah, pretty simple. And this is the else thing. So this is if the card did not work, we play the little note that didn't work, and we just do nothing, and then we stop, and then we delay, so like 100 milliseconds between it, so it doesn't like run it as fast as it possibly can. So this is the void to listen to the secret knock. So this is also once we do our first knock and it detects the first knock, it plays a sound, so it lets me know that it's now registering the knocks. So that's quite helpful. And then yeah. So this part of the code's a little more confusing. So it reads the knocks right here, and it stores them, and then it sets all the times up. So all these times right here, or made so it can determine the milliseconds between each knock, so it can match the code. And then it does the same thing right here. So the sensor value is bigger than the threshold, which is the threshold. It's like the percentage that we did up there. And then the current milliseconds are minus the past milliseconds or vice versa. And then it registers all the knocks like that. It stores all the numbers up. And if the numbers match the numbers that we have up there by a certain percentage, then it opens the door. See, trigger, unlock the door right here. And that's if all the numbers match up right here. And then we play the open melody right there. So, and this is the LED status right here, which we didn't really use at all. Um, so also this code had a new lock mechanism, which you can make a new lock, but again, the Arduino has to be on constantly 24/7 for you to be able to store new locks unless you want to go into to the memory that unless you want to go to the memory that was built in that can last with when you turn the Arduino off. But I didn't want to do that, so I took all of this out. I just deleted all of that. But in the original code, it was there. So yeah, this unlocks the door. We put it to true. The door is unlocked. Put a little sounds. Um, oh, this is how. Yeah, this is the validate lock code. A lot of functions to this. Lots and lots of functions, and it does what I said earlier. You know what I mean? It just counts the milliseconds between each knock, and if they're all accurate, all the same, then it opens the door for you. Yep. So that's how it all works. So the wiring for the knock lock is also very basic too. Um, Speaker, you just plug the speaker into the ground, and then you plug it into the digital pin, and the RFID module. You just plug it into. You can look up a diagram online, and that's what I did, and I got it. The knock lock sensor, the speaker, you plug it into A0 and then ground pin, and the other servo's very basic too, and then power is very basic. You VN then ground, but the capacitive sensor that's a little interesting. It's a high resistor, like a in the megas, like a mega ohm resistor, and you plug that into the ground pin, and you plug that into the digital pin, and then you have the wire that you want to touch connected on the ground side. So whenever you touch it, has to go through the resistor first before it can go into the digital pin. And if you look on the other side, you can see the switch that controls whether it's on RFID module mode or if it's on knock lock mode. And then this is the power switch right here. It's not hot glued. It came undone off the door. And the speaker that controls the knock lock, it also has the mega ohm resistor on it, and it has to be a very high resistor. If it's a low resistor, then you have to change the threshold to below 0, and that's impossible. So it has to be a very high resistor for it to understand and be able to detect the knocks. And then this is the RFD module, which is self-explanatory. So that's all the wiring for it, and that's the code. So I'll leave the code in the description below. If you have any questions, just let me know.